Okay, so now what I'm going to do is I'm going to make a vase, and I'm going to find the surface area and the volume of that vase. And so to start off, to make my vase, I'm going to have the function y equals negative x cubed plus 1. And you say, well, how does that make a vase? Well, here's what we're going to do. First off, we're not going to take that whole function. We're going to go from negative 1 to x to 0.7. Let's make that equals to, x 0.7. And you go, I still don't see a vase. Okay? That's fine. I understand that you still don't see a vase. So now what we're going to do is we're going to go 0 is less than or equal to y is less than or equal to minus x cubed plus 1, and again negative 1 is less than or equal to x is less than or equal to 0.7. And you go, gosh, I don't really see a vase. Well, that's fine. Now what we're going to do is we're going to take this little block and we're going to rotate it around the x-axis. So we're going to rotate it around the x-axis. And actually, graphing calculator isn't going to really let me do that, but we'll rotate it around the z-axis, and if we do that, we get that. So here is my vase. So I can stand it up like this, more or less, and there's my vase. And if I look at it, let me pull it around like this. Stop. That's where I want it. So now, if I zoom in on this, kind of rescale it a little bit. So I got that. That's the cross section. And then here you sort of see that I've got the same shape. So the radius of my vase is minus z cubed plus 1, or over on this side, y equals negative x cubed plus 1. So it doesn't really matter whether we're talking radius or y, or whether we're talking x's or z's. So this is basically the shape of my vase, and then I'm going to rotate that around the x-axis, and rotate that around the x-axis, and that's what I'm going to get. And so there's my vase. And so now I want to find the surface area of that vase. So I want to find out how much glaze I'd need to put on the outside of that vase to completely cover it, and we won't glaze the bottom, so we'll just sort of ignore the bottom there. Okay, so what I want to do is, rather than taking this whole thing, let's just consider a little narrow strip of it. Okay, so what I did is I had to sort of figure out how to make the graphing calculator do what I wanted it to do. So I've got this curve, y equals negative x cubed plus 1, and we're just chopping it from negative 1 to 0.7, and then we're rotating it around the x-axis, and so we're getting this, which is our nice little vase. Now what I want to do is I want to find the surface area of that vase. So what I'm going to do to find the surface area of that vase is I'm going to basically cut it into little strips. And so you can see now that this is a strip of my vase. So what I've done is, instead of going from z equals negative 1 to 0.7, I've gone from z equals 0.1 to 0.2. And so that gives me a little strip of my vase. And then this gives me my whole vase back. And so you can see that I can also change this. I can make another little strip if I wish. So there's another little strip. And so I could add up all of these strips and so you can see that I can take my little pink strip, and I can take my red strip, and I can take my blue strip, and I could keep adding strips. And once I added up all the strips, hang on. Once I add up all the strips, it'll give me that. Let's slow it down a little bit. So those are all the little strips, and then that's all the strips added together. I wonder if I can do this. Okay. So you get my point. Now, so what I need to do is I need to find what is the surface area of each of these strips. And so we're going to go to the graph paper and we're going to figure out what the surface area of each of those strips is. So going through this again, I'm going to sort of reduce my graph to a series of little rectangles like that. And that's dy and that's dx. And so then my surface, so then that length right there is going to be square root of dy dx squared plus 1 times dx. That's going to be the length of my hypotenuse. And so then to get that complete surface area, I'm going to integrate that. But now what I'm going to do is I'm going to make this into a strip. So what I'm going to do, this is going to be a little bit difficult for me to draw. I'm going to have my axis of rotation like that, and I'm going to have my little piece of curve right there, and then this is going to make an ellipse, and that's going to make an ellipse. And I'm sorry, my graphing calculator does it a lot better than I can draw. Let me give it another shot here. Okay, axis of rotation. Then what I'm going to do is basically I've got a little piece like that, and then I've got over here I've got a little piece like that. And so basically a very, very narrow ellipse. So there's my strip. So this is the front side of the strip, and that's the back side of the strip. Okay, I hope you can see what I'm getting at. Okay. Now, flipping it like that, this is my x-axis, this is my y-axis. So this distance here that's the same as up here. That distance there is going to be dy dx squared plus 1 times dx. Now, the circumference is going to be 2 pi r, but now my radius is y, or we could call it f of x. So I'm going to sort of switch notations here. And so my area of a strip of one strip is going to be 2 pi f of x times the square root of f prime of x squared plus 1 dx. And so then if I want to get whole surface area, that's going to be the integral from a to b of 2 pi f of x square root of f prime of x squared plus 1 dx. Now, back in the day, that would be really, really, really difficult to do. But now we got numerical integration is just everywhere. So if I've got my function y equals negative x cubed plus 1, then dy dx is equal to negative 3x squared. And so then dy dx squared is equal to 9x to the 4th. And so basically I'm going to find the integral from negative 1 to 0.7 of 2 pi my f of x, which is this, negative x cubed plus 1, times the square root of 9x to the 4th plus 1, all of that to the dx. Okay, so that looks really complicated, but I'm going to switch back over to the graphing calculator, flip into numerical integration mode, and presto changeo, I'm going to... Okay, so I'm back to my vase, and I'm going to go back over to my cross section. And what I'm going to do is I'm just going to use the numerical integration capabilities. So I'm going to take the integral from negative 1 to 0.7 of 2 times pi times negative x cubed plus 1 times 9x to the 4th plus 1 to the 0.5, and there you go, 17.925. 17.925. So the surface area, the exterior surface area of this object of revolution, of this vase, is going to be 17.925. So if it's square feet, I need 17.925 square feet of paint to paint the outside of that. And assuming it's impossibly thin, I need the same amount on the inside, and then if I really want to get into it, I could figure out what the surface area of that little disc is, and then I get the whole surface area of the vase. Okay, the next thing that I want to do is I want to figure out what is the volume of this vase. So I'm going to come back and I'm going to talk about volume in the next set of videos.